by Ben Blackman, Alex Kelly, and Cam Simpson. Introduction. Elizabeth's grandma is approaching her 99th birthday. She attributes her old age to a glass of grapefruit juice every morning. She says the acidity of the juice helps her liver to break down the toxins in her body. This is our prompt for Mr. Ross. We designed an investigation to test whether pH affects the activity of catalase. Hypothesis. We hypothesize that the change in pH closer to 0 or 14 will negatively impact catalase's function, and will therefore inhibit the ability to catalyze hydrogen peroxide, thus producing less oxygen.
Materials. Catalase, beef liver. 1 mole of hydrochloric acid. 1 mole of sodium hydroxide. Beakers, droppers, reaction chamber, paper disc, graduated cylinders, and a plastic tub. This was our procedure. First, we filled a tub with water and positioned the graduated cylinder upright with water, sealed by the surface of the water it is resting in. Add 10 milliliters of hydrogen peroxide to the bottom of the glass reaction chamber, along with 5 milliliters of either 1 mole of sodium hydroxide or 1 mole of hydrochloric acid. Put the reaction chamber in the water with the catalase-soaked disc on top side of the chamber, not yet touching the hydrogen peroxide. Place the tubing opening under the graduated cylinder. Flip the reaction chamber 180 degrees so that the hydrogen peroxide comes into contact with the disc, and shake slightly to fully mix the reactants and dislodge air bubbles. Measure the volume of oxygen every 30 seconds to determine the effects of the acid or base on the activity of the catalase.
These are our results. We measured oxygen produced in milliliters and the time interval every 30 seconds. Here's a diagram, a picture of our procedure. We also show these results in a graph next. As you can see, we had 6 trials. Each was measured over a time of 90 seconds with the milliliters shown of oxygen volume produced. We use this to measure the effects of acid and base on the activity of catalase and the reaction of hydrogen peroxide to produce oxygen.
Discussion. This is the reaction. The enzyme catalase catalyzes the decomposition of reaction of hydrogen peroxide into water and oxygen. Substrate effects. At a molecular level, a change in pH can alter the shape of the enzyme and its active site by adding or removing H ions, according to the needs of the acid or base. This can also change the charge and shape of the substrate and cause an inability for a reaction between enzyme and substrate. Therefore, a change in pH in the environment of a reaction will slow or stop the reaction. Hypothesis revisited and flaws. The experimental results do broadly agree with our hypothesis, as the reaction was far more limited by addition of acid or base and the subsequent change in pH. We predicted this to be true as we learned in class that the environment is crucial to an enzyme's ability to catalyze a reaction. Flaws. The experimental design had flaws in that the amount of oxygen flowing into the graduated cylinder changed depending on the angle of the reaction chamber and tubing. The solution is to have larger tubs, so it's easier to get the best angle every time.
Results in detail. We found that pH baseline reactions produced 55 to 70 milliliters of oxygen, and that the pH altered reactions never produced more than 10 to 14 milliliters at most. For all the altered pH tests, 7 milliliters was produced on average after 90 seconds, while 62.5 milliliters was produced on average from the baseline pH test in the 90s. Therefore, the change in pH limited the reaction on average to just 11.2% of its output. Therefore, a change in pH away from catalase's normal range does have an effect upon its activity.
Significance. The significance of this experiment is it shows the effect changes in pH can have on enzyme functionality in the body. A practical application of this lab could be to test new drugs and medication. It is known that some certain viruses, such as rhinoviruses and coronaviruses, that are most often responsible for the common cold and influenza viruses. These viruses function best when the host cell's membrane is at a low pH. Testing drugs that can increase intracellular pH could be beneficial in lowering the virus's severity and infectivity. Next steps. pH indicators could be used to measure pH more effectively and create a more complete experiment. Our experiment could have more accurately measured pH values in order to find the relationship between the pH of the reaction chamber and the production of oxygen, and therefore the effects of pH on the activity of catalase. A function could be created to show this relationship and could be applied to the effects of grapefruit juice in the liver. Conclusion.
Elizabeth's grandma thinks that acidity would help break down toxins. In fact, if the acidity did reach and affect her liver, it would impede the functions of the enzymes used to break down toxins and would not help her.